How many of you went back home, got your paper signed, and then after that your parents gave you a scolding? Okay. I'm surprised some of you get a scolding. I'm not sure why you get a scolding for. Okay. Okay, but I hope that whatever scolding you're going to receive, okay, I think it's even more productive, okay, if you actually act on the feedback that has been given, okay, and then obviously improve the next time round, alright? Okay, whatever has happened already. No point crying over spilled milk. Okay, that's how I feel. Alright, it's about really learning what has happened and then after that applying it to the next time. Okay, so let's move on. The last time round, okay, we started on algebra. Okay, so we were looking at basic algebraic concepts and notations. And then I recall that we actually left off with understanding, okay, what are certain vocabulary, important vocabulary in mathematics itself. Okay, so maybe let's just do a very quick recap. Okay, just want to find out, okay, what do you think 2 or maybe yes, 7m actually means? Okay, let's pick someone. Where are my ice cream sticks? Huh? Oh, it's funny inside. Yes, Ethan.
7 meters.
7 meters, 7 times m. Okay, so it means 7 times n, right? Okay, so this is the meaning. Okay, yes, I know that m is a unit. Okay, sometimes you see it as meters. Okay, but in this time we're looking at algebra, so it's 7 times m. Okay, thank you, Ethan. Right? What about 7m squared? Okay, what does 7m squared? Please don't tell me 7 meters squared. Yes, X?
7 times n times m.
7 times m times m. Okay? And then what if I have negative 7n? Let's change the letter, then g. Okay, bracket square, like that. What do you think it means? Yes, Lily? What? Sorry? Give it a try. Okay, negative 7 times g times negative 7 times g. Very good. Okay, and then how is it that we can simplify it? Okay, so actually later on we will learn that negative 7 times negative 7, we know that is equals to 49. Okay, so it's actually the same thing as 49 times g, which is actually 49g squared. Okay, just a big teaser, okay, for you of what's going to come next. Alright, so these are certain things that we covered previously, and also, okay, I introduced to use this thing called expression, okay, an algebraic expression, whereby if I have, let's say, 2x minus 5y squared, okay, plus 6, there are certain meaning to it, okay. How many terms are there in this statement? No, I don't want Kelly. Okay, Kelly already answered. Somebody else, please. Answer yes. 3, there are 3 terms. Let's see, do you agree? Okay, so there are 3 terms. You have 1, 2, 3, 3 terms. And then, what are the terms in this case? What are the terms? Yes, let's see. X, negative, sorry, what x? 2x. And 6. Okay, so we identify that there are 3 terms over here. We always take the operation that's in front, okay, not the one that comes at the back. So we see that the 3 terms are 2x minus 5y squared and 6 itself. Okay, so what are the variables then in this statement? Okay, what are the variables being used? Lucas A. What are variables? Let's do a recap. Do you remember what are variables? No? Anybody, any idea? Yes. What are variables? Yeah. The letters, okay? Very good. Variables are the letters, and in this case they are x and y. Great. Okay? So variables are x and y. Then after that, we also learned, okay, this thing called coefficient. Okay? So coefficient is dependent a variable. Okay, it is basically the number in front of the variable. So coefficient of the term 2x will actually be 2 itself. Okay, and the coefficient of negative 5y squared, what would it be? Yes, Ethan? Negative 5. Okay. Alright, and then the last thing is about constant term. Okay, and the constant term in this case of maybe Lucas take back to you. What's the constant term? Sorry? No variable. Okay, which term okay has no variables? 6. Okay, very good. So the constant term is 6. Alright, so these are words that you need to be familiar with, okay, and that was what I introduced to you the previous time round. Okay? So I want us to take a look at our textbook, page 97, the class discussion. Okay, the class discussion segment. Right? It is important for us to be able to translate okay, words that are given to us into algebraic terms. Okay, or in fact an algebraic expression itself. So let's look at part A. We have sum of 2x and 3z. What does sum means? Yes, yes. Huh? It means addition, okay? So in this case, sum of 2x and 3z will be addition. Addition of what and what? Okay, Zayden, what do you think? Maybe today I don't need my ice cream 6 anymore, right? 2x and 3z, okay? So this is the algebraic expression that represents sum of 2x and 3z. Okay? Then part B, product of x and 7y. Okay, what does product actually means? Xavier. Product means multiply. Okay, so what are the two things we multiply in this case? X and 7y. Will you please take note? Okay, so x times 7y, right? But then, okay, we go back to what we learned. Okay, so earlier on when we talked about 7f, we know that it is 7 times f, right? Okay, so if I want to re-express this, I can write it as x times 7 times y. Right or not? Okay. Now, in our usual algebra writing, we always put the number in front, the letters come at the back. Okay. For good practice, our letters also usually are arranged in alphabetical order. Okay, but then that's not the most important thing. Okay, but most important thing is that the numbers should come in front. So to rearrange this, we know that x times 7 times y is the same as 7 times x times y, because multiplication works that way, right? 2 times 3 is the same as 3 times 2. I can shift our things around. Okay, so 7 times x times y would then be the same as 7xy, because I mentioned that we don't really need to put the times, okay, intentionally. Okay, so we can always just drop off the times. If I don't write any times, it means that they are multiplication. Right? Next part C. Okay, we want to divide 3AB by 2C. Okay, so how will you go about expressing this, Joel? How will you write this? Divide 3AB by 2C. How will you write it? We need divide, right? Okay, so we need a division sign. Can you tell me what comes here and what comes here? What should be here? 3AB. Okay, so we have 3AB over here, and then what's over here? Joel, what's going to be over here? Okay, so the question says divide 3AB by 2C. So first of all, we need to recognize 3AB as a group. Okay, it is a number as a group in total. Okay, then divide by 2C. Right, so this is how we can write it. Alternatively, we also understand about fraction lines. Okay, I can also write it as 3ab over 2c. So sometimes writing it in a fraction will be more helpful. Okay, especially later on when we do more algebra. Okay. Then part B. Subtract 6q from 10z. Okay, so what do you think we should be getting for subtract 6q from 10z? Gigi, what do you think? 10z minus 6q. Okay, so Gigi says 10z minus 6q. Right, how many of you agree with me? Okay, will anybody think that it is 6q minus 10z? No? Okay, so I'm glad that we don't think this way. Why? Because we say that subtract 6q from 10z. So it must be 10z coming first. From there, then we take out the 6q. So that's why 6q comes after that. So that's a little bit of a tricky thing, okay, that we need to take note of when it comes to subtraction. Okay, so which one comes first and which one comes next? Next, we need to actually look at it carefully. Unlike earlier on, right, the first one we will just follow through. Okay, x and then 7y, 3ab and then 2c. Okay, so for subtraction, it may not actually work that way. Alright. Next, we look at part E. Okay, part E gave us an expression already. What we need to do is to figure out, okay, how to write this out in words. Okay, would anyone want to give this a try? Okay, how do we actually describe this thing in words? I just said how we have done it earlier on. Yes, let's see. Okay, wait, subtract the product of x and y from the sum of p and q. Okay, I want us to look carefully at this statement. Okay, do you think it makes sense to the p plus q bracket minus xy? It says subtract the product of x and y from the sum of p and q. Okay, do we agree with this? See what you think. Do you agree? Yes? Okay, then maybe Carmen, what do you think? You wouldn't agree? Then could you propose how will you write it then? Wait, let's hear from Carmen first. Yes, Carmen. Give it a try. How will you phrase this? Alright, sometimes think first. Okay, you think first, I come back to you. Evan, just now you wanted to say something. Put to, put to the, okay, okay. Sorry, it's just my own spelling mistake. Okay, let's see, Faith, you got anything? Wait, that's Yushin, sorry, Faith is inside. Sorry, my bad. Okay, yes, Faith. Any suggestion, or do you agree with this one? You agree? Okay. Then Tracy also agree. Yushen, yes, back to you. You agree with this? Okay. So I think seems like everybody is agree with Ati. Okay. I guess maybe it could be friendship. I'm not sure. Okay, but let's really look at it. Okay, it says subtract the product of x and y from. Okay, so that means that x, y must actually come at the back. Product of x and y must come at the back. Okay, from what? From the sum of p and q. So p and q must come first. Okay, and very importantly, we must have brackets around this. Okay, therefore you need to express it as the sum of p and q. Another way of writing it, okay, if you really don't want to break it down into product of x and y, sum of p and q, okay, it is actually possible to follow something similar. to A, B, C, and D. I'm not saying that this is wrong, this is perfect, I feel. Okay, but I want to show an alternative is that you can say subtract xy from P plus Q. This is also fine. Okay, simple terms. Okay, just that this is very much in its full expanded form. Okay. Next, we look at part F. Oh yeah, I suddenly remember we got homework due today, right? Oh, you don't put inside the file? Yeah, but I haven't even collect homework, you put inside the file. What? Yeah, that because I need to mark it first, right? And you put it inside. Okay, now by later then you know about it. Okay, later. Finish this one first. Sorry, no wonder I thought something is not right. Okay. So continue on part F. It says 3 plus y over 5. Okay. So how will we write this 3 plus y over 5? How will we write this? Asher. Divide 5 from, is it what? What is it? Divide what?
From the sum of y.
From the sum of 3 and y. Okay? What do you think about this statement? What do you think? How many of you will agree? Who would disagree? Okay, so Tracy, why do you disagree? Should be the opposite. Divide 3 and y from divide the sum of 3 and y from 5. Okay, so Tracy is recommending this. Divide the sum of 3 and y from 5. So what's correct? Yes, Evan. You got something to say? You want to add? Okay, add. Okay, give another answer. Yes, sure. Okay, so Evan gives an alternative. Divide the sum of 3 and 5 by 3 and y, by 5. Okay, so we got 3 different options now. Okay, Colin, why don't you make a decision? Which one do you prefer, or which one do you think you agree? The blue one, purple one, or the red one? The red one. Okay, how many of you will actually agree with the red one? Okay, alright. So these two, okay, what is the problem over here? Okay, I agree that the red one is the answer. Okay, what is the issue in these two? Okay, it is because of the word from. Usually we don't say divide from something. Okay, we divide by something. Right, so it's a little bit of English over there. Okay, so that's why we don't say, I wouldn't agree with this because of the word from. Okay, we can subtract from something, but we don't divide from something. Okay, then likewise over here, okay, this one the sequencing wouldn't be correct really. Okay, because it says divide the sum of 3 and y from 5, which I think it isn't making much sense now, okay, especially with the word from itself. Okay, so I think Evan's answer is good. Divide the sum of 3 and y by 5. Okay, similar to how we actually phrase it in part C itself. Alright. Next, we look at part G. Okay, we have this. How would we actually phrase this then? Okay, Hansha, you want to give this a try? Sorry, the square root of B? So you want to start with the square root of B. Subtract. Then what? Subtract 2c. Okay. Is it, Hansha says this, the square root of B subtract 2c. Okay, so looks like a lot of people have things to comment on. Maybe let's see the nearest partner, Roses. Okay, subtract 2c from the square root of b. Okay, is this better now? Okay, so that was the issue. Okay, actually there's nothing quite wrong, okay, with Hansha's answer if instead of using the word subtract, okay, he say the square root of b minus 2c. Okay, so it's about how the English word is being used. Okay, so we can say minus, nothing wrong with that. Okay, but Rose's answer is very good in terms of using the word and subtract. So we're subtracting 2c from the square root of b. Now what if I want to lengthen this further? Yes, Evan, you want to ask a question first? There are 2 square roots of b. If it's a whole number, okay. Now, I think Evan asked a very good question. He asked, okay, there are 2 square roots of b if b is a whole number. Now, when we did our WA, we said that a square root, okay, of a number, there are usually 2 square roots, right? Positive and negative numbers. But then, when I use this symbol, when I say it in words, right, okay, there will be 2 square roots. But when I use this symbol, it only represents the positive square root. So down here is only one number itself. Okay? So, subtract 2c from the square root of b isn't wrong at all. Okay? Any comments? Okay, now what if I really want to further expand this statement? Okay, instead of saying 2c, okay, how else would I actually phrase this? Francis, what do you think? How do I expand on this 2c idea? Subtract what?
Subtract 2 times c.
Subtract 2 times c. Can you use proper mathematical words instead of times? Yeah, subtract what? Instead of 2 times c, can you give me something else? Product, use the word product, please.
Subtract product of 2 and c.
Okay, the product of
2 and c.
2 and c
From the square root of b.
from the square root of b. Okay? Great. Right, so this one is this answer. Okay? So there are 3 alternatives over here for part G itself. Okay, either one is actually fine, whereas part F we only accepted this one. Okay. Any other questions? Right. If no questions, okay, let me look at the time. Our lesson started at 8. Okay. I just want to finish up H, I, and J out. Okay. Before I go into your homework. Do you have any problems doing homework? Any problems in doing homework? Don't have got problems. How about you look at me like that? Anybody has problems doing homework so that I can manage the time? Okay. Then I don't want to dedicate so much time to going through homework then. Okay, let's look at part H. Okay, I don't want to write down the whole question, so do it with me. It says that there are 3 times as many girls as boys in the school. Okay? Find an expression in terms of x for the total number of students in the school, where x represents the number of boys in the school. So x represents the number of boys. Okay? And then the question says that there are 3 times as many girls. So I'm just writing the key phrases here. Okay, 3 times as many girls as boys. And then the question wants us to find an expression. In terms of x. Okay, for total number of students. Right, so these 3 very important statements given in the question itself. Okay, so first of all, since we know that x represents the number of boys, how would we write the number of girls in the school? Okay, yes, Ethan, fastest hand first. 3x, okay? Because it says 3 times as many, so the number of girls can be written as 3x. Okay? Now the question is saying that you want to find the total number of students. boys together. Number of boys is just X. Number of girls is 3X. Okay? So you think of X as a group itself, okay, plus 3 groups of the same thing. So total, how many are there? Okay, Ethan, you have spoken too much. Okay, let's see Inky. Yes, Inky. How many X's are there in total? 4X. Wait. Okay. So we should get 4X in total. Okay. Later on, we will be looking at addition and subtraction of the algebra also. Okay, so we need to know that X plus 3X is equals to 4X. Okay, next we look at part I. Okay, it says that Nadia's father is 3 times as old as her. Okay, father is 3 times as old. And then the brother is 5 years older. Okay, find an expression in terms of y for the sum of their ages. Okay, so find in terms of y an expression for the sum of their ages, where y represents Nadia's age. Okay. Now something I forgot to mention just now. Okay, you will find that in your questions usually. Okay, the question will usually phrase it in this manner. Find an expression in terms of x. So I wrote this the other way around. Find an expression in terms of y. Okay, so you must understand what you're trying to go for. You're trying to get an algebraic expression that looks like this. Okay, so in this case, okay, let's break it down part by part. Okay, Evan has been very persistent in raising his hand. Yes, Evan, what do you want to answer? The whole day, okay, never mind. Let's break it down part by part. Okay, how old is the father? Father's age. Okay, father's age, Evan says that it is 3y because 3 times, okay, of Nadia's age. Okay, Trina, can you tell me how old is the brother? Yes, Trina. Y plus 5. Okay, so 5 years older means we add 5 years to the brother's age. Okay, now in total, okay, what will we be getting there? I see Zayden spacing out. Zayden, come back and tell me what is the total sum of their ages. 3y plus y plus 5 plus y. Okay, if I want to go about simplifying this, okay, so just like what we did with the x plus 3x to 4x, okay, we want to simplify it. What will we get? Yes, Xavier. 5y plus 5. Okay, so we have 3y over here plus 1y plus another y. That means we have total of 5y. Okay, and then plus another 5. We will get 5y plus 5 as the total age of everyone. Okay. Okay, I'll give part J a miss. Alright. Okay, so that's the end of our class discussion segment. Okay, so I just want to finish up this 4.1. Okay, by looking at this practice now 1. Okay. Okay, one important algebra, okay, is to know how to find out the value of an expression when the question has given us what does x and y represent. Okay, so that's why our question usually they will say evaluate. Evaluate means that we find out what is the value. Okay, we need to go and calculate. So we are given that x is -2, y is equals to 4. Okay, so if I want to find out what is 5y minus 4x, we know that 5y means 5 times y. So if I want to replace the y with the 4, I should have 5 bracket 4 because our brackets serve the function of multiplication. Okay, then after that minus away 4 bracket x is now -2 bracket -2. Okay, so when we replace a number, okay, for the individual variables that we have, we must put brackets around it. Okay, I cannot just happily put the numbers in without the brackets because that means 54 minus 4 minus 2. Totally different meaning from this one. Okay, so you cannot write it this way. Alright, so 5 bracket 4 minus 4 minus 4 minus 4 times -2. You just have to press into your calculator, no need to do mental sum, and what will we get? 26. Okay. Okay, but of course you can do mental sum if you want to lah. 5 times 4 is 20. -4 times -2 is a plus 6. Plus 8 is it 26? It's 28, right? I got cheated. 28, right? Okay, so just use calculator. Okay, but if you really want to calculate it mentally, 5 times 4 is 20. Minus 4 and -2, okay, become a positive 8. So therefore we get 8. Okay. Next we look at part 2. Okay, or part B. Part B we have 1 over x minus y plus 3. Okay, so x is -2. In this case, we see that our x is actually in the denominator. Okay, so that means that x in the denominator, I will write it like that. It is actually fine if you don't have the brackets. Okay, so have brackets, don't have brackets, also okay. Right? So I'll just leave it there as it is. Y is 4 plus 3. Okay, notice that I don't really have brackets when I replace, okay, the x and y in this case. Okay, because the thing is that there is no product, there is no multiplication going on. I needed these brackets to show the multiplication, whereas over here it's just 1 over x. X is alone itself, so don't really need to have the brackets. Likewise for the y, okay, if you want to have the brackets, it will look like that. Okay, but it doesn't make a difference because it's still minus 4 after all. Okay, so you can key this into your calculator. Okay, we have -½ minus 4 plus 3. That will give us -1.5, or if you want to write it as a mixed number, also can, -1.5. Okay, either one is okay. Okay, questions? One last one, question 2. Okay, we want to find the value of p squared plus 3q squared when p equals to -½ and q equals to -2. Okay, so now p squared, p is supposed to be -½ So we know that brackets matter. In this case, the square is for all of p, so there must be brackets around the -½ and then for q, you must have brackets around the -2. Okay, if you are still not very confident when it comes to brackets, okay, especially when you replace the letters with numbers, then may I suggest that every time you replace, you just put brackets first. Okay, until you get yourself stronger in these algebraic concepts. Right? So p squared, okay, would negative half square. Press into your calculator, okay, this entire expression, right? Then what will you get? 12 and 12.25, or you want to leave it as mixed number, also can, 12 and 1/4. Okay? Questions? Okay. If no questions, alright, that's all for our chapter 4.1 today. Okay. I want you to take out your 3B homework. Okay. If you have submitted your 3B homework, you in your file, can you please come here and then find your file? Okay. So for homework exercise 4A, I want you to do question 1, B, C, okay, 2B, 2C, 3A, 3D, 7, and 8D. You have it? Okay? Okay, this is due on Friday, yes. Okay? Okay, same expectations apply, Question number on one side, okay, each line is a blank. Okay?